Okay, before we do any simulations, these two questions at the top are kind of a little bit of review of combinations, but in concert with probability. Okay, so these are kind of tricky questions, so we're going to go through them together. Okay, so this says, what is the theoretical probability of being dealt exactly 2 sevens in a 5-card hand from just a normal deck of cards? So it says 52-card deck, no jokers or anything bizarre like that. What is the probability that this would happen? Okay, so like I said, these are a little bit weird, so I'm going to kind of walk you through this a little bit. All right, so let me ask you a question real quick before we start. If I just deal you, let's say I deal you 5 cards, does the order I deal them to you matter? No. It does. Like if I get dealt a hand of cards, I always like reorganize them however I want them, right? It doesn't matter how you get, what order you get them in. It's going to be a combination, which is why we're going to use combinations for this. Because if I deal you 2 cards, you can put them in any order you want once you have them in your hand. Okay, so I'm going to do number of combinations. I'm going to write combos because I'm going to abbreviate that. Where I have 2 sevens. Okay, in the question it says exactly 2 sevens. Exactly is a fancy math word, not really a fancy math word, but it means only. I don't want 3 sevens, I only want 2 sevens. Okay, how many sevens do I have in a deck of cards? 4. Okay, so I have 4 total, and I'm going to do a combination. I only want, out of those 4, I only need 2 of them. So to set up the combination there, it's going to be 4 choose 2. So 4 sevens. Okay, now if I have a 5-card hand, how many more cards would I need to get after the 2 sevens? 3 more. Okay, so I'm going to write number of combos of 3 non-7 cards. Because I don't want a 7 again. I only want 2 sevens, so I want the other 3 cards to be anything but a 7. Okay, so if I remove the 7s from a deck of cards, how many would we have left? 48. Okay, now I need 3 more cards for my 5-card hand, so this would be 48. And I just need any 3 cards as long as they're not a 7. So that would be that. Okay, so to get the total number of cards that I would have that would just have 2 sevens, we would take these 2 and multiply them together. This will give us the total number. That'll be all the hands I could do that only had 2 sevens. Okay, now we're doing a probability here. So I want to know the probability I get one of these hands if, I'm just going to write number of combos of 5-card hand. So if I just have a normal deck of cards, how many combinations would we have if we needed 5 cards in our hand? Like, how would I set that up? No requirements or anything. I'm just going to deal you 5 cards. How would I set up that I need 5 cards out of a deck of cards? Exactly. So 52. Choose 5. That would be all the possibilities for any 5-card hand. That is going to go on the bottom of the fraction to create the probability there. Okay, now we're going to use the calculator to do this, of course. So if you do have an 83, or if you have an 84 that takes physical batteries, you have to type the number first before you get into the math menu to get the combination. If you have an 84 that plugs into that thing back there, then you shouldn't have to do this. Okay, so and if you have an 84 like I have right here, you can type the number first if you want, but it's math and then the probability menu. We're doing combinations. It's the 3rd thing. And I'm just going to arrow over and I'm going to multiply that by 48, choose 3. So you can actually do this all in one step if you want to, but I'm just going to show you separately the top and bottom number here so you can see it. So out of the number of hands I could have, there'd be 103,776 different ways you could get 2 sevens in your hand. Okay, now the total number of cards, this is a huge number. So 52, choose 5. There are 2,598,960 different hands of cards that you could be dealt if you're just dealt 5 cards out of a normal deck. Okay, so to get our probability, we want to divide those two. Okay, now this is very small, so 0.0399. So if I told you, like, what's the percent chance that this would happen, what would you guess? Or what would you say for that question? About 4%, right? I'd round that up, just move that decimal place over. So this is about 4%. 4% chance you get 2 sevens in your hand. Okay, now I'm going to try one more, just see if you get the hang of this. Okay, what's the theoretical, I can't speak, theoretical probability of being dealt exactly, meaning only 3 aces, and that we're going to do a 5-card hand again from a standard deck. Okay, so how would you write 3 aces as a combination? Exactly. There's 4 of each thing in a deck of cards if you don't know that. So there's 4 aces and I need 3 of them this time. Okay, now how many more cards do I need to fill out my 5-card hand here? 2, because I'm going to do 3 aces, so I need 2 more cards. So I need 2 non-ace cards. So we're going to think about removing all the aces from the deck. So we take 4 out of the deck and any other card. Go ahead. All right, so what would I write down as my combination for getting 2 cards that are not aces? What do you think? Exactly. So we do 48, choose 2. Okay, now multiply these 2 together. That'll give you the total number of hands that would have 3 aces and then just 2 other cards. This is much smaller number than the one we just looked at. Okay, so this is only 4,512, so much smaller number. And the bottom of the fraction should still be exactly the same as what we did on the last question, because the total number of 5-card hands is still that 2,598,960. So I'm just going to take my number that I just got there, divide that. Now, as you guys can see, I'm going to write this as a decimal just real quick. This would be 0.00. I'm going to do a couple more than I normally do. This is a super, super tiny percentage. Okay, if I multiplied that by 100, that would give me the percent chance this would happen. It's not even 1%. It would be 0.17% chance that would happen. So super, super small percent chance that that would happen. Does anybody have any questions? Okay. Now, we're going to use the calculator to do these other questions, but we're going to work on these things in there called simulations today. Okay, now I'm just going to do a little example. We're going to pretend we're going to flip a coin, okay? Find the theoretical probability you flip tails. Theoretical, and you guys will see this on the assignment a little bit, it's also called a uniform probability model. It'll be what you expect to happen. Okay. So if I flip a coin 10 times, how many times should I get tails, theoretically? 5, right? Okay, so this would be 5 times, right? The probability there would be 0.5 or 50%, if you want to write that. Okay, what if I flipped a coin 100 times? How many times would you expect to get tails? 50. And then, again, the probability would be exactly the same. What if you flipped it 500 times? How many tails should I get? 250. Okay, so this makes sense to you guys. 250 times here, and 1,000, you'd get 500, right? All right, now we're going to do a little simulation and compare this to what we think should happen. Okay, so to do this, and this is why you're going to want an 84. And you can write down my data on my calculator, or you can write down yours. It's your choice, whatever your preference is. You're going to hit the button that says apps. It's actually right next to the math button that we've been using. Okay, now these are in different places on different calculators. Most people, I think it's number 9. On my calculator, it's number 10. But you want to look for the option that says PROBSIM, stands for probability simulation. You're just going to hit enter, and it's going to take you to this lovely screen here. And there's different things you can do, but what we're going to do is we're going to toss coins. So this is where it gets a little weird. When you get into this menu, to do anything, you got to use the 5 keys across the top, and they're going to match up with what it says here on the bottom of the screen. I'll go back. I can't go back. Go to apps. Do you have the... It's right underneath the math, or right next to the math button. You found it? Okay. Is anybody else, sorry, having trouble? Okay. Go. Some of them just aren't programmed with it. Okay. All right, so you guys just go to the screen that said coin toss. So I just hit the Y equals. What is going on? Don't tell me. I don't want to know. Okay. Now, okay. So across this, I'm going to hit, let me see if I can get this focused a little bit more. Okay. You want to hit the window button to toss a coin. Okay. And then it's just going to literally simulate that for you. So we're going to go up to 10. So just make sure that number in the upper left corner will tell you how many times you did it. So just do that up to 10. Okay. Now, you guys, this might look like mine. You guys, this might look totally different. So if you want to record my data or your data, it doesn't matter. Okay, so these are kind of hard to read. Like I look at that bar graph and I see on my particular example, I got more tails, but I don't really know how many more. You can have the calculator tell you. If you just use like the left and right arrow keys, it'll actually highlight one of them, and then up here it'll say frequency. So that'll tell you exactly how many. So mine that I have on the screen right now, I got 6 tails and 4 heads is what I have. So my experimental probability then would be that I got 6 times on my experimental probability. Probability of that then would be 60%, which is obviously different than what you guys have on the theoretical. Okay, the next one says 100, and you guys can toss 10 at a time. I'm going to toss 10 at a time just to get up to 50. And then when I get up to 50, I'm going to toss 50 at a time to get up to 100. And thank you. Huh? Just the left and right, hit the left and right key, and it'll tell you across the top actually how many. Now, mine is actually at this point, mine is 50-50. So I got 50 times here. That's what I would expect to happen. Yours might be different. So just write down, if you want to write down yours or if you want to write down mine, that's fine too. And then we're going to, once we got that, just toss up to 500. I would use the 50 key. It'll go faster. Sorry, it doesn't do more than that at one time. And on mine, I got 252, so maybe yours is different. I'm just going to write down that percentage real quick. And then we're going to toss up to 1,000. So if you get to 500, and you can use my data or you can use yours, whatever you want to do. Oh my. All right, I got 499. Okay. Anybody have the window or anything? Are we doing okay? Hit the window button.
How do you get out? Hit the plus 10 or plus 50 dollars.
Oh, you can just hit escape button. It's hard to get out. Yes. Wait, how do you do it? Just do like 238.
What?
How do you escape? Okay, cool. That's fine. Okay, so I'm just gonna just do it.
No, Tails had a huge lead now.
Did you just say tails have a huge lead?
No, Tails have it. Oh.
Yeah,
501 to 499.
that's what I got too. That's exactly what I got. Okay. Now, you guys, and we could, like, if we could keep going with this. Like, I don't know, I'm just generating some numbers here, and I don't know if this is gonna be good or not, but I'm just moving some more. Maybe I'll get up. Okay, I got 1,600. Okay, now, the theory behind this, which is what's underneath this lovely little table here, is called the law of large numbers. And I should have done more trials to kind of illustrate this for you guys better. But the law of large numbers is going to say with a large number of trials, your experimental probability should approach the theoretical probability. Now, on my second example was exactly what it should have been, and then I was a little off. But you can see my first toss, I was at 0.6, and it should have been 0.5 theoretically. The more times you do the trials, it should approach the actual theoretical probability. So if I had done this like 7,000 times or something, it should be really, really close, if not on 50%. That's called the law of large numbers. The more trials you do, the experimental approaches the theoretical. So that's just a little example. Okay, now, the other simulation we're going to do here in a second is not in this menu, and I don't know why it's designed this way, but I feel like these are really hard to get in and out of. So to get out of this, you can't just quit, and it won't even let you turn your calculator off, I don't think. So you want to, across the bottom here, the escape, that's what the ESC stands for, hit that, and then you have to hit it again, and then it's going to be like, are you super sure you want to leave this awesome probability model? And you have to say yes. And then over here, once you're on that screen where it gave you the different options, you have to go over to the graph button, hit quit, and then it's going to say, are you really sure again? And then you're going to say yes with the Y equals button, and then finally it should take you back to the main screen. But it's a little bit of a project to get out of that. So don't think you're doing anything wrong, but it's got to be a couple of steps to get out of that menu. Okay. Now, what we just did is an example of using some technology to basically speed up the process of doing trials. We're not going to sit there and flip a coin 1,000 times. That would take forever. Okay, so, yes, exactly. So, we use the technology to do that for us, and that's going to be called a simulation. So, you just did a simulation by practicing with the calculator there. We're going to do a different type of simulation for this other example, and we'll do that in 1 second. So, okay, this one says, on a 10-question multiple choice quiz, each item has 4 choices, so like A, B, C, D, and only one is correct. How could you simulate guessing randomly for each question? Okay, so this is a little weird, but the calculator is only going to assign numbers to things, so I can't use A, B, C, D. So what I'm going to say is I'm going to let 1 represent the correct answer. So if I have 4 choices, only one of them's right. That means the other 3 are wrong. So in our simulation, I'm going to let 2, 3, and 4 represent the wrong answer. Okay, now what we're going to do for this simulation, we're going to use a random number generator to do this. Now the 83 and the 84 both do this, and I'm going to walk you through on mine with the 84 up here. But if you have an 83, the directions are really similar. They just look a little bit different once we get into the screen, but this is not under that same apps menu. Okay, so if you guys have your calculator, you're going to hit the math button, and we're going to get into that probability menu. And it is, on mine, it's right under the factorial. It's number 5. It should say RAND. That stands for random, and the INT stands for integer. Okay, now this is where I'm going to hit enter. This is where we'll differ. If you have an 84, your screen probably looks like mine. We want to generate random numbers 1 through 4. So for the lower limit, I put 1. For the upper limit, I put 4. And the N is the number of questions that are on the quiz. It told me in the question that there were 10 questions on the quiz, so that's a 10. Now, the only difference is going to be if you have an 83, it will just literally pop up parentheses. It will not pop up the screen. You just type the number 1, use the comma key. It's right above the 7. Type the number 4, comma, and then type 10 and close the parentheses, and it will do the same thing. Okay, now why it says paste, I don't know. So we're just going to hit enter, and it should take you back to the main screen. And if you have an 83, this is what it should look like. And then just go ahead and hit enter. And what that's going to do, it's going to generate 10 random numbers between 1 and 4. And I'm just going to jot these down real quick on my paper. So if you want to use yours or you want to use mine, that is totally up to you. Okay, so either write down mine or write down what you got on your calculator, either one. Okay, so based on how I set up this simulation, if you want to look at mine just for 1 second, how many answers did I get correct? Just 1. Okay, now, the number 1 represents a correct answer. All the others represent the wrong answer. Okay, so if I was doing this has got 10 questions, so that person would have gotten 10% on this one. If yours is different, do yours. Okay, now I'm going to generate this again for another trial. Okay, guys, shh. Okay, all you have to do, you don't have to go back into that screen, just literally hit the enter button and it'll generate another set of 10 numbers for you. Okay, now, if you want to use mine, you can, or use what you've got. Now, on this one, I only had 2 ones, so this one I would get 20% of my quiz correct. And we're just going to keep doing this. So, remember, the number 1 represents a correct answer. Any other number represents a wrong answer. So for the number correct, just how many 1s do you have? Wow, well, that's not one of the right answers, though. Okay. Oh, last period, the highest I got was 30, so I'm already doing better in this class. So. Darn it, my person is stupid here. Okay. Or they're not, they're just a bad guesser, I guess. They're a bad guesser. Oh, no, I did not have that yet today, so, and I still don't. Okay, good. I didn't get higher than 3 last period, so. Oh man, this is not going well. I'm not even on the screen anymore. Sorry guys, let me move that up. Oh yes, okay.
She just got 16.
Yes, I got 6 right on that one, which is still enough, but whatever. Okay. Now, based on your simulation, I don't know if you got, I should have made this smaller so I could fit this on the screen, but based on the simulation, it says, what's the probability you pass the quiz? Okay, now last period I had to put 0. This period though, okay, so only one of these would work on my example. So if you don't have any that are 60% or over, your probability is 0. So my probability would be 1 out of 10 trials. Now, theoretically, we should probably do more trials than this to get a better example going. But it's very low probability that you would get even a passing grade if you just guessed on all the questions. So the moral of the story is you should study for your quizzes, okay? Could, you could. I don't know. It might be right, it might not be. Okay, is anybody having a question about how to generate these or anything like that? Okay,